How's it going, everyone? The question I'm answering in this video is why does it tend to be warmer when it snows? And the first part of that answer is, well, is that actually true? Or does it only seem that way? And well, it's kind of true. Okay, sometimes it gets warmer when it snows. Sometimes it gets colder when it snows. Sometimes the temperature stays the same and it starts snowing. But if the temperature goes from cold to warmer, you're more likely to get snow than if the temperature goes from warm to colder. So there is something to the question of, well, why does it tend to be warmer when it snows? Okay. The other part of the answer here is that when you have really, really cold temperatures, these really deep freezes, it's quite likely that you're going to have very clear skies, very sunny, not a cloud in the sky, and the temperature is very, very, very cold. And of course, it's not going to be snowing at all because there's no clouds in the sky. And that also adds to this perception of, oh, it tends to be warmer when it snows. Okay, so I'm going to explain why that happens. And the first thing to explain is, well, why does it snow? Okay, well, in the air, in clouds, you have water vapor, which is the gas form of water. And if that water vapor cools down sufficiently, it'll turn into liquid, and then it'll turn into ice. And liquid and ice is denser than water vapor. Okay, so it will start falling, and you get snow. Okay. So, well, how does that happen? Okay, so if you have a pocket of warm air and you cool it down sufficiently and there's enough water vapor in that air, well, that water vapor will turn to ice and the snow will start falling. Okay. Now, by the way, when we say warm air here, we're talking relatively. Okay, we're still talking outdoor winter conditions, right? Just warmer than the colder kind of outdoor winter conditions. So, well, if you have a pocket of warm air and a pocket of cold air and they start mixing, then the warm air is going to start cooling down and the water vapor will eventually turn to ice and the snow starts falling. Okay, so you need warm and cold air to mix, okay, for there to be snow. Okay, well, there's two ways that can happen. Okay, you can have a pocket of cold air sitting around and warm air moves onto it, and that can cause a lot of snow. Or you can have a pocket of warm air sitting around and cold air moves into it. That's actually not going to cause as much snow because that warm and cold air is not going to mix that much. Okay, and I'm going to explain why. And to explain why, we have to talk about, well, what exactly is temperature? Okay, so you have everything made out of particles, and those particles are moving around, they're colliding with each other, they're being knocked out of the way by other particles. And temperature is a measure of how fast, on average, these particles are knocking into each other, colliding, knocking other particles out of the way. Okay, you touch a hot stove and you feel that. What you're feeling is, oh, the particles on the surface of that stove, they're moving around really fast. Okay, and you step outside into the cold air. What are you feeling? You feel, oh, the air particles outside are moving around a lot slower than the ones indoors. Okay, and what happens as a result, okay, is if you take a pocket of cold air, for example, the particles are not hitting each other that fast. Okay, they're not colliding that fast. They're not being knocked into different directions as fast. So after collisions, they don't move as far away. And so they stay closer to each other. And so cold air is quite dense. Okay? Whereas if you have warm air, well, in warm air, those particles are colliding into each other quite fast. They're being knocked away fast, right? So they move away farther. And so warm air is more well, the particles in it are more widespread, right? So warm air is not as dense, okay? Cold air, particles are not hitting each other as quickly. They're not being knocked out of the way. as hard, so they don't fly away as far, so they end up closer together. Okay, so in cold air, the particles are closer together, they are more dense. Now, what does that mean? Okay, well, that means if you have two pockets of air, okay, and one is cold and the other is warm, and let's say these pockets are the same size, well, the cold air has particles that are closer together, so more particles are going to fit in that pocket. The warm air has particles farther apart, so less particles are going to fit in that pocket, okay? And technically, we say the warm air is less dense, and as a result, you have pockets of the same size. The warm air pocket with less particles is going to be lighter, okay, because there's less particles there. That's why we say warm air is lighter. That's why we say hot air rises. That's why hot air does in fact rise. The colder air sinks lower, right, pushing the warmer air up. The warmer air floats up higher. So, let's say you're on the surface of the Earth and you're experiencing some cold conditions. Okay, so there is a pocket of cold air right where you live. All right, and warm air moves onto it. Okay, so you got your house, wherever it is you live, big pocket of cold air over your city, and warm air moves onto it. Well, that cold air is a big, dense, heavy thing. And the warm air moving onto it, okay, well, this is a less dense, less heavy thing. It's not going to do a very good job of pushing that cold air out of the way. Okay, imagine this is like a pillow hitting a bag of sand. Okay, that bag of sand is not going to move much. And because that warm air is lighter, it's actually going to creep above the cold air and end up just resting on top of it like a blanket. So you have this blanket of warm air on top of the cold air. Well, what's going to happen? The warm air is going to start cooling down. The water vapor within it is going to start turning into ice. That ice is denser than air, than water vapor, than air, and it's going to start falling, right? And so you have lots and lots of snowflakes dumped down onto the ground. Okay, so what happens from the perspective of the observer on the ground, right? They were sitting in this pocket of cold air. A warm air blanket ended up on top of it. As that warm air starts cooling down and producing snow, well, the cold air also starts warming up because it's interacting with the warm air, right? The cold air is warming up. So if you're sitting on the ground, what do you experience? First you experience it's cold, then you experience, oh, it's warming up, and as it's warming up, what else is happening? Lots and lots of snow is being dumped down onto you. Okay, so when you have these heavy snowfalls, it's more likely that that's caused by warm air moving over top of a pocket of cold air, and things are also warming up as you experience that. Now, why can't that happen the other way around? Okay, let's say you're on the ground, okay, you got your house, and you're surrounded by a pocket of warm air. Okay, and so you're feeling relatively warm conditions, and a bunch of cold air moves in. Well, then the warm and cold air will mix as well, right? And the cold air will cool down as well, right? Not exactly, okay? Because remember, the cold air is a lot more dense. You got a big, dense, heavy thing hitting something that's not as heavy. It's not as dense, okay? So this is not the pillow being thrown into a bag of sand, okay? This is a bag of sand being thrown into a pillow. That pillow is going to go flying, okay? And what's going to happen is that warm air is actually going to get pushed out of the way in a whole bunch of directions. It'll also be pushed up, right? Because it is lighter than that cold air. And rather than this kind of blanket of one type of air over the other, what you end up with is the cold air just moves in, pushing the warm air out of the way, and the warm air is just going to go in in all directions, mostly up, but other directions as well. Okay? And so you, the individual, on the ground, well, what do you experience? Well, it was warm, and now it's become cold. Okay? Because you're not under a pocket of warm air anymore, you're under a pocket of cold air. Okay? Well, what about the warm air? Didn't some of it cool down, right? And as a result, didn't some of that water vapor turn to ice? Yeah, but it's somewhere else now. Okay? It was knocked out of the way by that cold air. And so this warm air here, yeah, some of it before being knocked out of the way, there was some interaction. It might create some snow, but not where you are, somewhere else. Okay, this is a warm air pocket moving somewhere else. This warm air moving up into the atmosphere, yeah, some of that water vapor might have cooled down and become ice as it goes high up into the atmosphere. There's not as much of it if some snow does come down, right? Plus, air is less dense higher up in the atmosphere too, okay, and that affects the situation as well in certain ways. So yeah, you could get some snow when cold air is replacing warm air, but not as much because there's not as much mixing, because you don't have a blanket of warm air just sitting on cold air, stationary or practically stationary, cooling down, dumping snow on the same location. You don't have that. What you have instead is the cold air just knocking the warm air out of the way. Okay? There's not as much opportunity to mix, and the warm air that does cool down, it's moving, it's not staying in the same place, dumping snow over top of the same place, and there's not as much snow anyways. All right? So you're more likely to get snow if it gets warmer, right? If you're under a cold air pocket and a warm air pocket moves on top of you. Not so likely, not as likely to get snow if it gets colder, if you're in a warm air pocket and a cold air pocket comes and just knocks it out of the way. Okay. Another phenomenon that can happen is one of these deep freezes. Okay, so if you're in a place and there's a whole lot of cold air sitting on top of you, well, guess what? That's a big, heavy thing. It's a dense thing. It's sitting on top. It is difficult to move out of the way. So you're not going to have a lot of clouds moving into that area. So the skies are going to stay clear. So you're not going to have much precipitation. It's going to be very sunny and very cold because that cold air is just sitting there and nothing's moving it out of the way. Right? And that creates these like very cold, very sunny, clear sky conditions. And as a result, what do we perceive as humans? We're like, yeah, it tends to get warmer when it snows, right? We notice that intuition. Yeah, it happens often enough that maybe there's something to it. And the answer is there is something to it. And that's what it is. So I hope you enjoyed that. And I'll see you next time. Bye-bye.